Simultaneous equations involving trig, what's not to like? So we're going to approach this in the same kind of way you would normally and eliminate either sine 2x or cos 2x. I'll normally get like a y and an x and they're not interlinked, but actually here they are, and we're going to have to be a little bit careful along the way. I'm going to times the bottom one through by root 3 because then I'll get the same coefficients on the cos 2x, just opposite signs. So 3 sine 2x minus root 3 cos 2x is going to equal 3. And now I can add them together to eliminate these two. 4 sine 2x is equal to 2, and therefore sine 2x is equal to a half. Now you might just think, let's solve that, get the values of x, and we're done. But you've got to be a bit more careful in a normal simultaneous equation here because sine and cos are actually interlinked. It's not like if we had a y here, we wouldn't even need to worry about it, but we need to just also check that it's like all consistent with cos 2x, i.e. I'm going to solve for cos 2x as well. So before I solve for sine 2x, let's actually find out what cos 2x would be. So it would be a half plus root 3 cos 2x is minus 1. Therefore, root 3 cos 2x will equal minus 3 over 2. And therefore, cos 2x will equal minus 3 over 2 over root 3, which ends up being minus root 3 over 2. So I'm actually looking for values of x where both of those are satisfied. And you can see if I change the equation slightly, like put a 10 here or something, then I'd still be able to eliminate cos 2x in the same way, but now I'd get a different value of cos 2x itself when we sub back in. And you could even get like no solutions, even though you managed to get some solutions for sine 2x. It has to all be consistent. Okay, that's quite an interesting part of this question. So let's first of all look at the sine 2x equals a half. I think that's easier to solve. Now sine 30 is a half. That's one that we get. Let me draw out the sine graph. And then I could do 180 minus that to give me 150. So 2x could equal 30 or 150. And I get other solutions by then just adding on 360. So 390 or 510. I should have said at the start, actually, the range is going to be between 0 and 720. So that's it for 2x. Just got to now deal with the cos 2x equaling minus root 3 over 2. It's a little bit more awkward without a calculator to deal with that one, but cos 30 is root 3 over 2. And if I draw the cos graph, I can see that I've gone 30 away from the peak. So if I go to the minus peak where it's minus 1, if I go 30 either side here, I will hit minus root 3 over 2 as well. So that is at 180, and therefore I'm going to get 2x is equal to 150 or 210. Okay, from that. Another way to do it, if you didn't like that, is to say, right, I'm actually 60 away from here. So if I go another 60 here, I will also hit the minus root 3 over 2 because of the symmetry of the cos curve. So then it'd be 90 plus 60 is 150. And you could also do 60 back from this way, so 270 minus 60. Again, we get 150 and 210. You might have other ways to do it as well. That's just how I did it. And then again, add on 360, so we get 510 and 570. But just note, we're looking for where it's got to be consistent. So the 150s are okay, because they're in both, but the 30 is not, and the 210 is not, and the 510 are in both as well. So these are actually the two solutions for 2x to the simultaneous equations, which means x is going to equal 75 or 255. They're the two solutions. So the sum is then those two added together, which is going to be 345 to get to 300, and then add on another 30, it's going to be 330. Well done.